Hey guys, so today we're going to be talking about distance versus displacement. We talked about this briefly before with the paper airplane lab, and now we are going to actually apply it to some mathematical problems. The first thing that you are going to be asked to do is to provide a definition. I would like the dictionary definition, but for your own notes and sake, I'm going to give you an example of what the difference between distance and displacement actually is. So with distance and displacement, I'm going to use an analogy. An analogy is basically just a real-life example of what the concept is. So my real-life example that I'm going to be utilizing is a creepy neighbor watching your house, and specifically watching for your car. So let's say you go to work one day. You drive to work, you drive home, you park in the same exact spot. Your neighbor is creepy, and so he went outside at 7 o'clock in the morning and noticed that your car was still there. Then he went to bed because he works a night shift, because of course he does, because he's creepy. And then he comes out at 9 o'clock at night and notices that your car is parked in the exact same spot that it was at 7 a.m. that same morning. To your neighbor, you have not moved. As far as he knows, you have not left your house all day. So that is the displacement. It's your creepy neighbor. What your neighbor notices. Your distance, however, is your odometer. That's the actual amount that you have driven. Neighbor, what your neighbor notices. Odometer, what you actually did. Now that we know what distance and displacement actually are, we can start to actually apply it to a similar situation. So we're going to have a student that's going to be running around a square gym, and we're just going to go ahead and draw that square and pretend like it's a perfect square. In the actual instructions, it tells us that each side of the gym is 100 feet. It tells us this because we know that a square means that all of the sides of the gym are going to be the exact same, and all of the corners are going to be 90-degree angles. It also tells us that she's going to start in the middle of one of the walls. That means my differential between her and the corner of the gym on both sides is going to be 50 feet. My very first example, she is going to be running 400 total feet. If I run 400 total feet, I run 50, 150, 250, 350, 400. I have met to the exact same spot that I have been before. So my distance is 400 feet, because I ran 400 feet. Now my displacement is different. Let's say that someone was playing on their phone and didn't actually watch her run around the gym. They just happened to look up before she started and right after she got back. To them, it looks like she hasn't done anything, so her displacement in this case would be 0 feet. Now right now it looks like you're done with the problem. However, these units are still in feet, which is not acceptable. I want them in metric units, and I want them in meters. So we're going to actually be converting 400 feet into meters using dimensional analysis. Since I am looking for meters, I'm going to state that and say x meters equals 400 feet. The unit conversions that I gave you were that in 1 foot there are 12 inches, in 1 inch there are 2.54 centimeters, and in 100 centimeters there is 1 meter. So I'm going to use these particular conversion factors in my actual dimensional analysis. This is the unit conversion that I have that has feet in it, so I'm going to utilize that one. So 1 foot, 12 inches, 1 inch, 2.54 centimeters, sorry about that. And then of course 100 centimeters, 1 meter. The reason I placed each in their particular position is so that I can cancel them as I go. I have the unit on top and bottom, leaving me with only the unit that I was actually looking for. Once I plug it into the calculator, I will plug it in this way. 400 times 12 times 2.54 times 1 over 1 times 1 times 100. Parentheses are helpful. as they make sure that I don't actually have to watch what I'm doing, unless what I'm doing is typing in the wrong number. Okay, that gives me a different number than I got before. Let me check something. Yeah. Okay, I'm correct. Okay, so we got the total answer as 121.92, and the only unit I have left is meters. So my displacement, my final boxed answer for displacement, is actually going to be 121.92 meters. Luckily enough for me, my 0 feet very easily converts into 0 meters. So my final boxed answer for both are here.